We are going to talk about tangents. It is 6.8 in your notes, and we remember what tangent lines are. A tangent line intersects a circle at exactly one point that's called the point of tangency. So in our picture here, line AB is a tangent line. It intersects the circle at A, which is the point of tangency. So line AB is tangent to circle P. Remember that we name a circle by its center, and it's at A, the point of tangency. So right here, A is the point of tangency. So a line is tangent to a circle if and only if, I don't know if you remember us doing those conditional statements, but if and only if it is perpendicular to a radius drawn to the point of tangency. Perpendicular, I hope we all remember, means makes a right angle. So the radius is going to be perpendicular at the point of tangency to that tangent. So let's determine whether a segment is tangent to a circle. So if segment AB is tangent, then this, the radius, would make a right angle with it. And if it made a right angle, Pythagorean theorem would work on a triangle that we made by connecting the radius to the end of the tangent. So let's check and see. Does a squared plus b squared equal c squared? Well, if you put that in your calculator, you would see that 8 squared plus 15 squared is 289, and that 17 squared is 289. Those are the same. They do equal. So yes, AB is tangent to circle P. Let's check another one. If AB is tangent to the circle, then it's perpendicular to radius AP. Therefore, this would satisfy Pythagorean theorem. 11 squared plus 14 squared would equal, do you see how they only gave us this length? They gave us 5, but this is a radius. All radii are congruent, so we know it's 11. So what is the hypotenuse? 5 plus 11, it's 16. Now let's check and see, does 11 squared plus 14 squared equal 16 squared? Well, this is going to be 317. This is going to be 256. Those are not equal. So, no, that is not a tangent line. All right, let's move on to this problem, which says that, sorry about that, if segment JK is tangent to circle L. So what they're telling us, assume JK is tangent to to circle L. They're telling us it's tangent. If it's tangent, these are perpendicular, it would satisfy Pythagorean theorem, and we could find x. So 7 squared plus 19 squared would equal the hypotenuse squared. And we know that we can do a little shortcut and just put that in our calculator under the radical all in one step and save us some time. And x is 20.25. So here, JK, according to the directions, JK's tangent. So therefore, it would be perpendicular to the radius. If it's perpendicular to the radius, it would satisfy Pythagorean theorem. X squared plus 11 squared would equal the hypotenuse squared. Well, this is 7. This is a radius, so it's 11. Hypotenuse is 18. You remember that when we know the hypotenuse and we're trying to solve for a shorter piece, a leg, we subtract, and we could put it all under the radical in our calculator to do everything in one step and save time, and x is 14.25. Alrighty, let's go to another one. We know that JK is tangent to the circle, therefore it's perpendicular to the radius, therefore 10 squared plus 24 squared equals, what does it equal? X, what is that? That is x plus 10 squared. Well, we haven't done this in a while, have we? So I think maybe there's a shortcut here. Maybe there's an easier way to do this. If we said 10 squared plus 24 squared, and then we took the square root of both sides, the square root of 10 squared plus 24 squared is going to be 26. But when you take the square root of something squared, doesn't it just drop the squared and leave me with x plus 10? Yes, it does. So take away the 10 and x equals 16. That was not as hard as it looked, was it? It looked like we were going to have to square this, but if you go ahead and take square root of both sides, you don't have to do that. All right, one more. We have K is my tangent. So it would be perpendicular to the radius, which means it's perpendicular to the diameter because we can extend, there's the word I'm looking for, we can extend that to the diameter. So I should have, well, the radius is x. I've got to have two of them to get this side, so I've got 2x. So we have 2x squared plus 7, whoops, we got to put that in parentheses. 2x squared plus 7 squared equals 25 squared. What if I did it this way? Remember, I keep doing that wrong. Remember that when we know the hypotenuse, I'm going to run out of room, we can always subtract. I would subtract the 7 squared from both sides. Do you see how much easier it is if I don't go ahead and square it? If I just leave the squared and let the calculator do the work. So here, I'm going to take the square root of both sides so I can get just 2x, because the square root, I could have gone ahead and done the 2x squared and gotten 4x squared. It would have complicated things. So let's just take the square root of both sides. This is going to be 24, therefore x equals 12. So even though these problems look complicated, we can simplify them by not doing the math, not getting big numbers, but just taking square root before we do that. Let's just, I think we've done enough examples like that. Let's skip that one and let's do this one. So more tangent line properties. If two segments from the same external point are tangent to a circle, they are congruent. So I have a B tangent and BC tangent. They're both tangent from B. Therefore, I know that segment AB is congruent to segment BC. So we're going to use that in a moment to do some things. And then if a polygon is circumscribed, we've used the word inscribed, where the polygon is inside the circle. Circumscribed means it goes around the circle fits inside it completely. So all sides are tangent. It touches every side of the polygon at one point, therefore each side is tangent. Let's see how these properties can help us solve for missing information. Find each value, assume segments that appear to be tangent are tangent. So they're telling us these are tangent. Find the value of x. Do you see how AB and CB are both tangent from the same point, from B? That means these are congruent. That means I can say 8x minus 19 equals 5x plus 23. So what I can do is solve and get 3x equals 42. I'm gonna take shortcuts because we should all know how to solve equations by now. I'm gonna divide by 3. X is 14, and that's all it told us to find was x. We didn't have to plug it in. Okay, let's do another one. So SU and ST are both tangent at the same point. They come from S, therefore these are congruent. So it wants SV. It asks us a strange question. It asks us to find this. Well, we can't do anything till we find x. So we have 10x minus 41 equals 4x plus 7 because they're congruent. So as I said, I'm not going to go over the solving. I'm going to take some shortcuts here. 6x equals 48. Therefore, x equals 8. Now, plug it in. It doesn't matter which of these you plug it into. I'm probably going to use this one because they're smaller numbers and they're positive. 4 times 8 is 32 plus 7 is 39. That means that's not the hypotenuse. This is where they're perpendicular. That means this side is 39 because our radii are congruent. This is 17. What am I looking for? The hypotenuse. So I'm going to say that 17 squared plus 39 squared, if I take the square root of that, that will get me SV. So the square root of 39 squared plus 17 squared, the measure of SV is 42.54. All right, let's do one more. Here's the circle inscribed in the polygon. The polygon is circumscribed around the circle. That means all lines are tangent. That means this is congruent to this. So I know this is 16. That means this is congruent to this, 9.5. That means that this is congruent to this, 11. Now I can just add all the pieces together and get the perimeter. The perimeter is 73. And I will stop there.